Hello guys, welcome to Yebo Tutor Livestream help on this beautiful Wednesday. I hope everyone is doing good and everyone is enjoying at home. Just type in the comment section so that we can see where you are watching us from. We're gonna have maybe 30 minutes, then we can enjoy together. If you are a returning subscriber, thank you so much for tuning with us. And if it's your first time to watch us live, do subscribe. You can join our WhatsApp group in the description of this video. There is a link so that you can be able to receive the materials which we give students each week. I'm hoping that we are all happy and we can't wait to get down to the business of the day. Let's just wait maybe 30 seconds. Someone is also going to join. Just say hi. Just say hi. The idea behind everything is for us to interact. You can call us on Zoom. There's a QR code on your right hand side. Then you can call us on Zoom. Then we can interact. Or you can ask your question on the WhatsApp group which we have created so that we can know if you understand or you don't understand. Or you can type on the comment section of this video. Let's go, let's go, let's go, let's go, let's go, let's go. 2023 is our year for us to get distinctions. I'm hoping we'll be able to attain those distinctions. Okay, let's go. Let's get down to the business of the day. So last week when we met, we were doing number patterns, sequences, and series. So I did an overview and few examples. So today we're gonna do our first tutorial of the year. So on this tutorial, we'll be doing and we'll be focusing more on this question so that we can emphasize on the notes which we went through last week. So on this tutorial, we'll be doing past question paper from 2017, which was quite great, I think, because it consists of each and everything which we have covered last week. So today is going to be a quite good tutorial. So just type any question on the comment section on our YouTube so that we can be able to interact, guys. Maths is nice when we interact, when we speak with each other. So without wasting much time, let's dig in, let's dig in, let's dig in. So today we'll be doing 2017 November. So let's look at what we are given right now. Let's look at what we are given right now. So given the following quadratic number pattern, 5 is negative 4. So let's write it down. So question number 2, we are given a quadratic number pattern which is 5 is to negative 4 is to negative 19 is to negative 40. Great. Now, determine the constant second difference. So we were told in the statement that given the following quadratic equation, quadratic number pattern, sorry. So what is important and what is crucial is for us to understand what is a quadratic number pattern. So in order for us to answer the questions which are following 2.1.1, 2.1.2 until we reach to 2.1.3, it's so crucial for us to understand and conceptualize what you are being asked. So in this instance, they are talking about a quadratic number pattern. So what do we know about a quadratic number pattern? We know that it has a second constant difference, and the first difference of a quadratic number pattern makes up the arithmetic sequence. So now, in order for us to solve the question, they say determine the second constant difference of this sequence. So now let's just do it. As always, negative 4 minus 5, that's negative 9. Negative 19 minus 4, then we get our negative 15. Then negative 40 minus negative 19, then we get our negative 21. Okay, then we are on step number 2, step number 1. Now this is the first difference. Okay, this is our first difference. Now let's look for the second difference. Negative 15 minus 9 is gonna give us negative 6. Then negative 21 minus 15 is also gonna give us negative 6. So we can actually see that our second difference is constant. So just to recap again, this was easy. What do we know about a quadratic number pattern or quadratic sequence? We know that it has a second constant difference, and the first difference of a quadratic number pattern or quadratic sequence, it forms an arithmetic sequence. Then after that, we can be able to determine the second constant difference. So then therefore, our D will be equal to -6. Then you get your 2 marks, just like that, just for being able to solve that part. Now on 2.1.2, determine the nth term of the pattern. Wow, 4 marks for free. Why? Because we know that in order for us to determine the general term of a quadratic number quadratic sequence, we know that Tn is equal to an squared plus bn plus c. Now we must be able to calculate the value of a, the coefficient b, and also c. How do we do that? Let's go. 2a is equal to d, and what is d? D is our second constant difference. So we're gonna have 2a is equal to -6. We divide both sides by 2. We divide both sides by -2 so that we can get the value of a. Then our a is now equal to -3. Then now we are done. Now we want to know the value of b. It's easy because we know from last week that 3a plus b is equal to t2 minus t1. Great. Then what is the value of a? The value of a is the value which we have already calculated above. So we're going to have 3 times -3 plus b is equal to t2 minus t1. So t2 minus t1 is giving us -9. Okay. So now we have our -9. So 3 times -3, it's -3 plus b is equal to -9. Then our b is -9 plus 9, because we must make b the subject of the formula. The -9 plus 9, then we get 0. Then our value for b is 0. Now we want the value of c as well. Let's go. A plus b plus c is equal to t1. We already know this from our last session which we had last week. So today we are focusing more on doing questions so that it can be in our veins, it can be in our blood, so that we can dance when we are listening and solving, because this is nice. Great. Our a is -3, our b is 0. Now we want the value of c, and we were given our t1 to be 5. Where is it? Where is it? Here is it. It's 5. Great. Now we calculate c. C now is 5 plus 3. Then the value of c is equal to 8. Now we now have all the values. Now we conclude. Therefore, Tn is equal to, what was our value of a? It was -3 n squared plus 0 n, because the value of b was 0. So that is not important. Then we have our +8. Then we get 4 full marks. So when we are marking, we mark the value of a, 1 mark. We mark the value of b, 2 marks. We mark the value of c, 3 marks. And we mark the value of tn, and we have our 4 marks. So be aware, or be so sure about whatever you do, because mostly students love to leave it on this stage, that by just calculating the value of a, b, and c, and not concluding that Tn is equal to -3n squared plus 8. So if you don't conclude, you won't have any mark. You'll be marked partially and you have 3 out of 4. So please don't make those silly mistakes, because what we want is a distinction. Okay, let's move. Let's move. So now we are on 2.1.3. So on 2.1.3, the question says, let's read it together. Which term of the pattern will be equal to -25,939? Okay, cool. That's easy, because now they've already given us Tn must be equal to -25,939. So in other words, we must calculate the value of n. So now we already know our value of Tn, which is negative. Whew. Guys, can you still hear me? Um, can you still hear me so that we can proceed? So that we can proceed. Just give me 1 minute, guys. I just want to check some technical issue. Just want to check some technical issue. I'm sorry, guys. I'm back. It was just a small technical issue which I was supposed to handle, but now everything is now back and good. So let's go. Now, in order for us to solve this, now we say that we have already been given that Tn is equal to negative 25,939. So what do we do from this point? This is now easy because now we can actually see that this is like a quadratic equation. So now let's go. Let's solve this. So we now know that negative 3n squared is equal to, if we just let's do this, we just transpose everything. 0 is equal to 3n squared uh, minus 25,939 minus 8, because now we are transposing 8 as well to the other side. Then 0 is equal to 3n squared. Then if we use our calculator here, we're going to have negative 25,947. Now 3n squared is equal to 25,947. Then if we divide both sides by 3, now we're going to use our calculator now. So it's just your skills of algebra to be able to solve these questions. So n squared is equal to 325, 8, that's 8, remainder 1, 6, then 49. So always, guys, use your cashier calculator. Here is the cashier calculator. Always don't even try to solve by your head. You make yourself go crazy. So now we apply the root, but we know that when you're applying the root according to the rules of surds, you can have two answers, two solutions, positive or negative. So we apply our root here, then now we have n is equal to positive or minus. Then we use our calculator. So square root of uh, 8,649, then we get plus or minus 93. So you can write now n is equal to 93 or n is equal to negative 93. But we always know that we can't have a negative value. So now we conclude that therefore n is equal to 93. Then you get your all full 3 marks. So please, guys, always be aware that the moment they say that determine which term of the pattern, which means you're already given Tn, so you're gonna use the formula or the general term which you've calculated so that you can be able to get the correct answer. Now this is how you're gonna get your marks: 1 mark here, 1 mark here, and also 1 mark here, to be able to see that Tn is equal to this. Then you get your 3 marks. Now let's proceed, guys. Let's proceed. So now on the following question on 2.2, now we are now on 2.2. On 2.2, the question says, let's look at it together. The first 3 terms of an arithmetic sequence are 2, 2.2. They are 2k minus 7, k plus 8, and 2k, k, and 2k. Let's see that you can be able to see properly. We have our 2k minus 1. Okay, great. Now let's solve, guys. Let's solve. So they've told that this is an arithmetic sequence. So what does the question want? Because now we already know that a arithmetic sequence, it has the first constant difference. The first difference is just equal to each other. Now on 2.2.1, they say calculate the value of the 15th term of the sequence. So in order for us to calculate that, we must first know our general term. So let's solve first for the value of k. So we know that k plus 8 minus 2k minus 7, and also here it's going to be 2k minus 1, then k minus k plus 8. Why am I putting brackets? I am putting brackets so that you can be able to see on your own that this is crucial. Because if you don't put brackets, you won't be able to realize that negative times negative is going to be positive. You're just going to say negative 2k minus 7, of which that's going to give you a wrong answer. So please make sure that you put brackets always. So as we defined our arithmetic sequence, we already say that an arithmetic sequence, it's a sequence which has a first constant difference. So in other words, this difference here is equal to this difference which we have here. So let's equate the two. So k plus 8 minus 2k plus 7 is equal to 2k minus 1 minus k minus 8. Now we have negative k plus 15 is equal to k minus 9. Now when we transpose k, now we have negative 2k is equal to negative 9 minus 15. Then negative 2k is equal to 24. Okay, negative 2k, because when you say negative 9 minus 15, that's negative 24. Then you divide both sides by negative 2, then the value of k is equal to 12. Then from that point, now we now know the value of k. So now we can be able to determine the three terms of the sequence. How do we do that? We just substitute the value of k in this equation, which are in this pattern which we're given. So 2 times 12 minus 7, this now will be 2 times 12 is 24, 24 minus 7, then we get 17 here. Then 12 plus 8, that's 20. Then 2 times 12 is 24 minus 1, that's 24. Is it 24? It should be, let's just double check, it's 23, sorry for that part. So now we know our general terms in the sequence. So it's 17 is to 20 is to 23. And now the question was say determine the 15th term of the sequence. So now how do we determine that? Because we don't know anything about the sequence. But now, since now we know the values of the sequence, that they are 17, 20, and 23, now we can now be able to calculate and determine the T15th by now first determining the constant difference. So 20 minus 17, that's 3, and 23 minus 20 is also 3. Now, the general term or the general formula of an arithmetic sequence says Tn is equal to a plus n minus 1 multiplied by d. What is a? A is the first term in the sequence. So our Tn is equal to 17 plus n minus 1 multiplied by d, which is 3. Then let's go Tn is equal to 17 plus 3n minus 3. Then therefore our Tn will be 3n plus 17 minus 3, that's 14. Then after that, guys, we were asked to determine T15. So where there is n, now we are replacing with 15 because we want the n yet, that the 15th term. So now it's going to be 3 times 15 plus 14. 3 times 15, that's 45. 45 plus 14, that will give us 59. Then we get our all 5 marks. It was quite long, but it was worth it at the same time. It was worth it at the same time. Then we are happy. The next question says, calculate the sum of the first 30 even terms of this sequence. So we must underline that part. The first 30 even terms of this sequence. So this sequence 2.1 2.2.2. So this sequence of 17 is to 20 is to 23. So we only have one even term, which is 20. So let's have like maybe the next 3 terms or 4 terms of the sequence. So we're gonna have 23 plus 3, 26, 26 plus 3, that's 29, 29 plus 3, then we get 32. Okay, now we can see now we have 20, 26, and 32. So now the sequence of even numbers will be 20 is to 26 is to 32. Now, how do we calculate the sum of the first 30 even terms of this sequence? We know that Sn is equal to n over 2, 2a plus n minus 1 multiplied by d. What is our d? 26 minus 20, that's 6. Then what is our a? Our a is the first term of the sequence, just like that. Easy peasy. So we now want S30, which is the sum of the 30 terms. So it's going to be 30 divided by 2 multiplied by 2. Our a is 20 of the new sequence, because now bear in mind that we are dealing with the even terms of the sequence, plus 30 minus 1, and our d, we saw that it's 6. Then now we can use our Casio calculator. Okay, so 30 divided by 2, that's 15. 2 times 20, that's 40. 40 plus 29 times 6, then we multiply that 15. Then our answer is 3210. Just like that, you get your 4 marks. Pretty easy. We are done. Close that chapter. So what we were doing in these 2 questions, the first time we started by calculating and determining and working on the quadratic number pattern, and it was quite nice. It was quite great, because what we were dealing with is something which is so amazing, and it's allowing us to learn more questions on these quadratic number patterns. And what do we know? Just to recap, we know that a quadratic number pattern has a constant second difference, and the first difference of a quadratic number pattern is always an arithmetic sequence. Then on 2.2, we were given like an arithmetic sequence, which was also having like algebraic letters, which was k in this instance. So what was so important, or what we saw here, was that in this 2.2 we were given these values as well as the algebraic letters. So in order for us to work with this pattern or sequence, we started by determining the value of k. After we found that the value of k was 12, then we substituted that 12 into the original sequence. Then we got terms of the sequence. That's when we got 17 is to 20 is to 23. Then after that, we determined the Tn, or the general term of the arithmetic sequence. Then we found that it's 3n plus 14. But we have not yet answered what we were asked. We were asked to determine T15, or the 15th term of the sequence. So what do? We just substitute that T15 in the Tn, or in the general formula which we had. Then we get our answer, just like that. Just like that. Now let's move now to the next question, which is probably maybe the last question of the day. Let's see, what do we have here, which is question, yes, this is the last question of the day. Question 3. It's quite short. It's only like 2 questions. On question 3, a convergent geometric series. What is a convergent geometric series? When you are reading your maths, or when you are analyzing your question before you answer, ask yourself this simple question. What is a convergent geometric series? How do you see that this geometric series is converging? Oh, okay. Now you've answered that question. So whatever you are answering from other questions below is now on that part, that small part of understanding a convergent geometric series. So in this instance, let's go. So proceeding with what they've given us, it consists of only positive terms. And it has the first term a constant ratio r, and the nth term and the tn, such that that is a sign of sigma notation. If t1 plus t2 is equal to 2, write down an expression in terms of a and r. Okay, that one is quite easy, guys. That's easy peasy. Why? Because check it out. Last time when we are here, we say that the Tn 3.1, we say that the Tn of a geometric series is or geometric equation, geometric sequence, sorry, is ar n minus 1. Okay, so the first term is T1. Okay, so T1 is equal to ar1 minus 1. Then anything to the power of 0 is equal to 1. So now we only have a. So then therefore our T1 is a. Now our T2 is equal to AR2 minus 1. Then we get our T2 to be AR. So in this instance, they're just saying that write down an expression for A in terms of R. So in other words, just make A the subject of the formula. So if T1 plus T2 is equal to 2, is it? Yes. What is our T1? Our T1 is A plus, what is our T2? Our T2 is AR is equal to 2. Then we make A this like as a scalar multiply. Then we have 1 plus R equal to 2. Then now we make A the subject of the formula. Then we just divide by 1 plus R, we divide by 1 plus R. Then now we have our value of A to be equal to 2 over 1 plus R. Just like that, guys. You get your 2 marks, just like that, just for being able to see that part, how easy that is. Okay, now we are on question 3.2. Calculate the value of a and r. Okay, so this is quite great because we were given the statement showing us a convergent geometric series, and by the looks of the sigma notation we can see that it's starting from 3 to infinity. So how do we calculate the sum to infinity? You see, those are the questions. That's how you answer a question. You try to make sure that you break it down step by step, according to what you are given in the information. For the fact that we are having that sigma notation from n is equal to 3 to infinity, which means we are determining the sum to infinity. So sum to infinity can be equal to T1 plus T2, okay, plus our sum from n equal to 3 to infinity of Tn, of which this, when we were given in this question, we were told that this is 1 over 4. So our sum to infinity is equal to, this part we said it's equal to 2. You remember here? We said that it's 2. Then this part is 1 over 4. Then after that, what is sum to infinity? Sum to infinity always is a over 1 minus r equal to 2 plus 1 over 4. That should give us 9 over 4. Or just use your calculator, guys. Your Casio calculator, you have an answer fast. Now, from this point, everything is easy. Why is it easy? Because initially in the question which we did on 3.1, they say that write a in terms of r. So here we have a and we have already solved a on this part. So what do? Our lives are already easy. Where there is a, we substitute with the value which is here, which is 2 over 1 plus r. So let's go. So 2 over 1 plus r divided by 1 minus r. So this is the same as 9 over 4. But we know that if we are dividing, this is just the same as this part here is just the same as 2 over 1 plus r times 1 over 1 minus r. This is what we know, equal to 9 over 4, because we just reciprocate since we are dividing. Okay, then now we have 2 over 1 plus r, 1 minus r, equal to 9 over 4. So definitely we can see the denominator. This is a difference of 2 squares. So now we have 2 over 1, or we can just say r squared, minus 1, we can just say 1 minus r. 1 minus r squared equal to 9 over 4. Then after that, we can cross multiply to solve for r. Now we know that 2 by 4 is equal to 9. 1 minus r squared. Then 2 times 4 is 8, equal to 9 minus 9 r squared. Now transposing these values to the other side, then it's going to be 9 r squared minus, minus 9 plus 8 equal to 0. Then after that, we have 9r squared minus 1 is equal to 0. Then 9r squared is equal to 1. Divide both sides by 9. Divide both sides by 9. Then our r squared is equal to 1 over 9, like what we did before, plus or minus. Then we have our value of r to be positive or negative 1 over 3. But definitely our value of r is going to be positive 1 over 3. Okay, then after that, we now know the value of r to be equal to 1 over 3, because we always, most cases, we are looking at the positive numbers. Now we just go where we have the a as a subject of the formula here, then we substitute where there is r. So now we have a equal to 9, 1 minus 1 over 3 divided by 4. Then after that, you use your calculator to get the value of a. Then this will be 3 over 2. So we're able to solve this question. This question was so easy. Why was this question easy? It was easy because it started by giving us a hint on 3.1 that t plus 1 is equal to 2, and now they say write a in terms of r. So what did we do? We know that according to the geometric sequence general term, tn is equal to ar n minus 1. We can find, or we can know our first term, which is t1, and we can also know our t2. We just write as expressions. Then after that, we were able to realize that, oh, it's a plus ar equal to 2. Then after that, we saw that a is a common factor. Then we take the common factor out as a scalar multiply. Then we have 1 plus r. Then we ended up having these 2 marks here for saying a is equal to 2 over 1 plus r. In the next question now, they're saying that calculate the values of a and r. That's now easy because from the question which they gave us, they told us, and we also saw that this here, this part here is showing that we're gonna use the sum to infinity equation. Then the sum to infinity equation is always a over 1 minus r, because we can see that the value of n is starting from 3 going to infinity. So being able to analyze the question, being able to conceptualize is so crucial. Then t plus 2, we were already told from above that it's 2. Then this part here for infinity from 3 to infinity tn, we were given that it's 1 over 4. Then after that, we calculated that. Then this part, I think this question they were supposed to say on 3.2, hence calculate the value of a and r, because we are using what you have already calculated in 3.1. Then after that, we get our value of r and we get our value of a. Just like that, we are done. It was nice to have you guys. Is there any question? If you have any question, don't forget to just type on the comment section. You can also type on our WhatsApp group, which is in the link. You can also follow us on Facebook. We are always there. TikTok, on all social media platforms. Till we meet again, have a blessed night. I'll send the question as well in the group so that also people can have it and write maybe solutions, so that guys, you can receive the solutions from me on this beautiful Thursday. I'm signing out. Have a good night. and enjoy. You can still come back and look the video. The video always be available for you. Yango.